Hello friends, welcome to this third video on transformation of two-dimension random variable. In the first two videos, we saw about the transformation of the type u equal to xy and u equal to x divided by y. Now we will see what this video holds for us. The problem is, if x and y each follow an exponential distribution with parameter 1 and are going to be independent, find the PDF of the transformation u equal to x minus y. So the primary idea of transformation is transforming the set of variables x comma y, the two-dimensional random variable, to another set of random variables called as u comma v. So we have an old joint PDF for our f of x comma y, which we now transform it to the new joint PDF of u comma v. Now this is going to be aided by the Jacobian of the value. Now how to go about it? This is going to be very simple if you are going to follow a 6-step process. So come on, let us take them up one by one. Now the transformation which has been given for us is u equal to x minus y. So u has been fixed for us, but the second value v hasn't been fixed for me. So what we do in the step 1 is we fix the auxiliary random variable y as v. So v is now assigned to our y. So this is going to be mapped over here. So we have u to be defined as well as v to be defined. So now we can transform the random variables. Step 2. Fix the joint PDF of f of x comma y. Only if we know the joint PDF f of x comma y, the old one, we will be able to transform it to the new one. But how to fix the new one? We have been given information about the random variable x and y. We have been said that x and y follow exponential distribution with parameter 1. What is going to be the PDF of an exponential distribution? If x follows exponential distribution, then we say that f of x is lambda e power minus lambda x, valid for x greater than or equal to 0, and is going to be 0 elsewhere. The quantity lambda is called as the parameter of the distribution. So this is the PDF of an exponential distribution. Now we have been mentioned that this is going to follow with parameter as 1, which means lambda is taken as 1. Now what we have over here after replacing it is f of x is equal to e power minus this lambda is also replaced with 1. So e power minus x, valid for x greater than or equal to 0. So now this is my new f of x. Now how about my y? Y also follows exponential distribution with parameter 1. So in a similar fashion, rewriting it for f of y, we have this to be equal to e power minus y, valid for y greater than or equal to 0. So my f of y is got. Now we need f of x comma y. How to get about it? We have been given the third information that x and y are independent. If x and y are independent, we know that f of x comma y can be written as f of x product f of y. So this is going to be the criteria for my independence. So using this, we compute the old function join PDF f of x comma y as e power minus x product e power minus y. I can write it as e power minus of x plus y, valid for x greater than or equal to 0 and y greater than or equal to 0. So this is my old function f of x comma y, the joint PDF of x and y, which has to be transformed. We move on to step 3, finding the relationship of the variables x and y in terms of u and v. What do we know about the first step? The first step fixes v as y. So we know that v equal to y. So I want x and y in terms of u and v. So now y is fixed as v. Now how about my x? What do you know about the relationship u is equal to x minus y? U equal to x minus y. I want x. So bring it to the opposite side. X can be rewritten as u. Take y to the opposite side. So this will give me plus y. What do you know about y? Y can be replaced as v. So x now becomes u plus v. So I have now the value of x and y in terms of u and v. The next thing is to form the Jacobi of the transformation. So Jacobi requires the partial derivative of the x and y with respect to u and v. So in the next stage, let us compute dou x with respect to dou u. X with respect to u with respect to u is 1 and v with respect to u is 0. So the total value is 1. Now dou x with respect to dou v will be v with respect to u is 0, v with respect to v is going to be equal to 1. Next, dou y with respect to dou u, we don't have any u over here, so the value is 0. And when we have dou y with respect to dou v, we this have as v with respect to v as 1. So the Jacobi of the value will be equal to 1, 1, 0, 1. So when we cross multiply, the answer leaves the Jacobi value to equal to 1. So Jacobi has been got. Using our step 2 and step 3, we will be able to fix the new transformation f of u comma v given by Jacobi times f of x comma y. So Jacobi f of u comma v is Jacobi. What is the Jacobi value we attained? 1 times f of x comma y. What was f of x comma y? E power minus x plus y. So you replace this as e power minus x plus y. Now the glitch to be cleared over here is I want a function of u and v, but I have the variables x and y. They have to be eliminated. So how to eliminate them? Replace using these using the uh, relationship which we have just now found. So x can be replaced as u plus v, x can be replaced as u plus v, and y can be replaced as v. So now this gives me the new function f of u comma v as e power minus u plus 2 times of v. So now I have got the new joint PDF of u and v as e power minus u plus 2v. Now moving on to the next thing, what is required for the function to be completely defined is the range space of the variables u and v. So now what is going to be the range space of the old variables? The range space of my x and y. We have been said that it is going to follow exponential distribution. For an exponential distribution, x is valid for all the values greater than or equal to 0, y is valid for greater than or equal to 0. So we will plot the values x greater than or equal to 0 and y greater than or equal to 0. So how will this line now look like? So we have our y-axis and we have our x-axis. So we have this to be of the format. The line y-axis represents x equal to 0 and now this represents y equal to 0. When I want greater than x, this part is less than x, this part is going to be greater x. X moves as 0, 1, 2, 3 up to infinity. So this is greater than 0. Similarly, this is y equal to 0. When I move downwards, it is minus 1, minus 2 and so on. Y greater than or equal to 0 is y equal to 1, 2, 3. You will have to move in this way. So if I move in this way, what is going to be x greater than or equal to 0 and y greater than or equal to 0? This is going to now cover my entire of my space over here in the first quadrant. This is my x greater than or equal to 0, which covers over here. And now when it comes to your y greater than or equal to 0, you have it over here covered in this way. So you have the entire first quadrant. The space is going to be the entire first quadrant. Now we will see what happens with the space of your u and v. What is going to be the variations for u and v? How do we have defined our ux? X has been defined as u plus v and y has been defined as v. So now replacing this, you will have u plus v to be greater than or equal to 0 and v is going to be greater than or equal to 0. Now a point to ponder over here, you have addition of two elements to be greater and one element is already greater. Say suppose you have two elements over here. I have 3. Say I have 1 plus 3. This is going to be 3 plus 1, which is going to be equal to greater than or equal to 0. There can be one more choice that this number can also be negative, in which case also the sum will be greater. If I am going to fix my v as 3, if I have 3, if u is going to be minus 1, then what will happen? Minus 1 plus 3 gives you 2, which is still going to be greater than or equal to 0. So for the case that u plus v is going to be greater than or equal to 0, with one number already greater than 0, which means that you can either be positive or you can be negative. So I need to take care of both the cases. This is my case 1 where u is positive, the case 2 when u is going to be negative. Now we will try to plot these quantities and visualize how things are going to work for us. So we will plot the v-axis and then our u-axis. So this is going to be my v and this is going to be my u. Okay, now when the case we have u plus v is greater than or equal to 0, when both the case u and v are going to be positive, so I can have case 1 to be v is positive, u is also positive, in which case the addition is going to be positive. So where is going to be the line v equal to 0? This is my line v equal to 0. Which is my line u is equal to 0? This is my line u equal to 0. Which is going to be u and v both greater than 0? Now u and v both greater than 0 is going to appear in this space. This is going to be the space in the first quadrant where I have both the quantities u and v to be greater than 0. Okay. So we have both u greater than or equal to 0 and v greater than or equal to 0 in my first quadrant. Now coming to my case 2, what is going to be my case 2? My case 2 is that my v is positive, but I can say that my u can take a negative value. So how to predict it? Then my v will be greater than or equal to, take this u to the opposite side. So what will happen? It will be greater than or equal to minus u. So we will first plot the line v equal to minus u. So what will be v equal to minus u? When v takes the value 0, u will take the value 0. When v takes the value 1, u takes the value minus 1. So you have the line to pass through the point 0, 0 and minus 1, 1. Where is the point 0, 0? This is the point 0, 0. Where will the point minus 1, 1 lie? In u-axis you want minus 1 and in v-axis you want it to be equal to 1. So this is going to be my point minus 1, 1. So now draw a line which is going to pass through this point 0, 0 and this point 1, minus 1. So how will the line look like? This is my line which is going to be required and is given by the name v equal to minus u. So this is going to be my line v equal to minus u. So you notice that this is going to be, say, suppose you take it to be equal to 3. What will be the numbers for which it is going to turn out to be positive? When I have minus 1 and 0, then it is positive. What happens when it is going to exceed minus 1? So when it is going to exceed minus 1, the value will be equal to minus 2. What will happen for minus 2? Minus 2 plus 3, again it is going to be equal to positive. But what will happen when you have minus 3 plus 3? Again, this will be equal to 0. What happens when it goes for minus 4 plus 3? Now happens the case where the value turns out to be negative. So for the region inside this, the addition will remain positive. When it is going to exceed the value of 3, it is going to be greater than or equal to 3, or if it is going to be greater than or equal to v, then what will happen? This will be turning the addition as negative. So the required region again will be of the format. What will be the case? You will be having it as v equal to minus u. In this portion, again the sum of the two variables will be positive in nature. So we have the case when we can separate this into two cases. This is going to be the case for your u going to be greater than or equal to 0, and this is going to be the case where u is going to be less than or equal to 0. So when your u turns out to be negative, this is the values, and u turns out to be positive, this is going to be the value. So we have defined the range space. Now moving on to the last stage, what we require is the PDF of u. How to get the PDF of u? It is integral of your function which you have got and integrate with respect to dv. Now comes your function which we have got, e power minus u plus 2v. So it is e power minus u into e power minus 2v with respect to dv. Now the point is to find the limit of v. Now we can see from the range space, v varies in two different ways in two different cases. One is for the case when u is positive, v is also positive. For the case u is less than 0, v is negative, then the v varies differently. So I cannot write this as one single function, but what do I do is I write it as rather two functions, e power minus u, e power minus 2v for u greater than or equal to 0, and then you have it as e power minus u e power minus 2v dv for u less than 0. Now let me fix the case for u greater than 0. I want dv. What is dv? Direction of v. What you will have to do? Draw a strip parallel in the direction of your v. So when I draw a strip parallel in the direction of v, then what will happen? My v varies from over here to the top. So what is going to be v in the bottom? V in the bottom is v is 0. What happens at the top? V turns out as v equal to infinity. So where does my v vary from? V varies from 0 to infinity. V varies from 0 to infinity. This is for the case when u is going to be positive. Now when u is going to be negative, let us come to the second portion. When u is going to be negative, this is going to be my case. What is the line? This line is called as v equal to minus u. And now when I draw a strip, where does it move from? From the lower end, your V, to the upper end it goes on. So what is going to be my lower limit? My lower limit has been given as V equal to minus U. And what can you say about the upper limit? Upper limit is V equal to infinity. So for the second case, when U is negative, my V varies from minus U to infinity. So you don't have a single function, but the function behaves differently for two different portions, u being positive and u being negative. So we will have to integrate them separately. So now moving on to the next slide for integration. So integral v equal to 0 to infinity e power minus u is a constant with respect to the variable dv. So take it outside, just e power minus 2v will be there inside. You integrate it with respect to v. E power minus u e power minus 2v divided by minus 2. Apply the limit 0 to infinity. This gives me e power minus u. Applying the upper limit, v takes the value infinity. We know that, keep in mind, e power minus infinity is 0. E power 0 is 1. So now when we move on, applying e power minus infinity, the quantity becomes 0 minus lower limit 0. E power 0 makes it as 1 divided by minus 2. Minus minus cancels off. So I have it as e power minus u divided by 2 for which range? U greater than or equal to 0. So now let me move on to find for the case u less than 0. So for u less than 0, what happens? V varies from minus u to infinity. So varying from minus u to infinity. Again, e power minus u is a constant. We will keep e power minus 2v dv alone inside. So e power minus u e power minus 2v divided by minus 2. Now apply the limit from infinity to minus u. So it is e power minus u. Again applying v as minus infinity. E power minus infinity is 0. So upper limit vanishes. Minus lower limit, v takes the lower limit minus u. Minus 2 into minus u. So you have e power minus 2 into minus u divided by minus 2. So this is my lower limit. So this minus on minus cancels off, leaving you with e power minus u. E power, this is going to be positive 2u divided by 2. When we club both of them, so this gives me 2u minus u. So that makes it as positive u. So e power positive u divided by 2, and this is for the case u less than 0. So I have two functions, and hence now for my f of u I am going to define it as, so what is my PDF f of u? F of u is going to be equal to the upper function for u greater than or equal to 0. The value taken is e power minus u by 2. So go and fix it. E power minus u by 2 for u greater than or equal to 0. And for the second case, when u is less than 0, what happens? It is e power u divided by 2. So it is e power u divided by 2 for u less than 0. So always keep in mind, don't club and add them as one function, because the nature or the behavior of u is different in two different zones. So over here in positive zone it behaves differently, In the negative zone, it behaves differently. So please don't add the functions. You will have to write it as a split function or a multiple function f1 and f2. Okay. So after applying all the 6 steps, we have now arrived at the desired state, the PDF of our function u. Thank you.